Dear students, in the last few couple of classes, we have started the applications of integration. In the applications of integration, we have done with the areas where to find out the area between a curve and x-axis, and also we have done with the area to in between the two curves, how much area is being occupied. So now we are entering into the third application of integration, where the volume is being generated when some functions or the curves have been revoluted around the axis. Let us say now in this way, let us consider, suppose the curve is being, the function y is equal to f of x is being revoluted about the x-axis, let us say about the x-axis, like this. Suppose now the volume is being generated, right, and it is also generated, and you can say that this is a typical cross section, of course, of the solid perpendicular to the axis, correct? It is a perpendicular to the axis of revolution, you can say. This is what, then when the axis of revolution is happening, a solid has been generated. So now what is the radius? The disk is being generated, right? So what is the radius? Suppose let us consider this is the radius of the disk is called, let us say, r of x. Then what can you say about the area of the disk? It's in the circular shape, right? So the area of the disk is what given by, it is pi times of r of x the whole pi r square, right? So it is pi times of r of x the whole square. So similarly, if you have the function where, let us say like this, now it is x and this is y, let us say. Again, now the function is being revoluted about the y-axis, let us say. Again, a solid has been generated, the volume has been generated when by the revolution, and of course this is the cross section of the solid which is perpendicular to the y-axis of revolution. Okay, this is the disk of radius, and even here it is what, let us say now the radius is r of y, let us say. Then what is the area of the disk? It is pi times of r of y the whole square. Now what happens? Depending upon the radius, slowly we can find out the volumes, right? The volume of this particular after the volume has been generated when you have revoluted, right? So now the volume is being given by the formula. Now from which element, from which point to which point, it is a to b. Let us say this is from a to b again. So like this, suppose when you say, then the volume is being generated from the point A to B, and this pi r squares are being formed. So it is pi times of, if it is about the x-axis, then if it is revoluted about the x-axis, then it is pi times of f of x the whole square dx. Understood? And if it is, this is when the revolution happened about the x-axis, about the x-axis. And then volume of the solid generated when it is been revoluted, when pi into f of y the whole square, then dy about the y-axis. So this is what the formula to find out the volume of the solid generated by the revolution of the curve about the x-axis as well as the y-axis. So this is what the problem. Now this is what one application. Now let us start doing with some problems here. Let us say, find the volume generated, find the volume generated by revolving the region between y-axis and the curve, given by x is equal to 2 over y, and the limits of y are from 1 to 4. So this is what the question about the y-axis, that is already given between about the y-axis. So it is clear that about the y-axis the revolution has been happened and hence the solid is been generated. So what is the volume formula? It is integral of, the limits are what? 1 to 4. Now pi times of, now the function is about the y-axis. So it is 2 by y the whole square dy. So now 2 square means what? 4. 4 pi I will take out. 4 pi times of integral 1 to 4 1 over y square dy. It's clear, I think, right? So it is 4 pi times of integral of y power minus 2 dy. Now what it gives you? It is 4 pi times of, what is integral y power minus 2? Y power minus 1 over minus 1, that is minus 4 pi times of 1 by y. 1 by y. Now the limits are from 1 to 4, right? So just substitute the limits from 1 to 4. Then that gives you minus 4 pi times of, upper limit is 1 by 4, lower limit is 1. So what is this giving you? It is 1 by 4 minus 1 will be minus 3 by 4. 4 gets cancelled and minus gets cancelled. So it is 3 pi cube volume. No, it is. So it is 3 pi cubic units. I hope you are able to understand. So this is what the solution. So I have just done the calculation here. If you want, I will do once again here the calculation. 4 pi times of 1 by 4 minus 1. How can you write it as? Minus 4 by 4. We can write to make the denominator same. So it is minus 4 pi times of 1 minus 4 is minus 3 by 4. 4 gets cancelled, plus 3 pi is the cubic units. It's a very simple and easiest technique to find out the volume of the solid generated by the revolution of the curve. Now, let us do one more problem on this volume. Let us take the problem as find the volume generated by the curve. I'm taking one practice problem here. Try to understand the region bounded by the y-axis, and the curve y is equal to x cube between y is equal to 1 to 8 is revolved about y-axis. Find the volume. So let us now solve this problem now. The region bounded by y-axis, y is equal to x cube. So what is the volume formula? It is integral of pi times of y means x cube the whole square. The limits he has given you that 1 to 8 dx. That's it. So simple problem it is. So take pi outside, integral 1 to 8 x power cube the whole square, x power 6 dx. So what is this value giving you? Pi times of x power 6 integral is x power 7 over 7 over 1 to 8. So that is pi by 7 times of 8 power 7 minus 1 power 7. So you can do this calculation. What is the calculation for this? It comes around, yeah, it is y is x cube 8 power 7 minus 1. Let's do the calculation here. It is 8 power 7 is this minus 1 is this into pi is this divided by 7. 941.199. Pi times of x cube the whole square dx is x power 6 within the limits 1 to 8 it is, right? 58.4 cubic units it is.